Hello, my noble viewers. Welcome back again to my YouTube channel. I'm still your teacher, Maryesther. I welcome to my page named Chemistry with Maryesther. If you've not subscribed, you go subscribe. Call on your friends, follow my page, and you'll be able to understand chemistry better. Now let's go. Today, we'll be looking at a very important topic that cuts across other topics in chemistry. That is valency. Valency. Most students find it difficult. I wonder why. But with this video, after watching this video, you'll be clarified. Valency has to do with the combining power of an element. Valency is the combining power of an element. What authority it has. What it can use to bond. What will give it credibility in bonding. What will the element bring to the table when the element wants to bond with another element? That is valency. Now, after this topic, you will be able to understand the difference between metals and non-metals when it comes to electron gain or loss, without wasting time, without stressing yourself. You can be sleeping, and when someone calls you and calls an element and asks you, this element, is it a metal or non-metal? You will not even hesitate. You can give the answer without stress, even without going to the periodic table. Let's go. Having said that valency is the combining power of an element, now we're going to use the idea of arrangement of electrons around the nucleus of an atom. You know, an atom has a nucleus, and electrons are arranged round the nucleus of an atom. This is an electron. This is the nucleus of an atom. And this is the shell. In my last video, I talked about that shell has to do with period, and the valence electron has to do with the group. But that's not the topic. Now, having said that, this electron in the outermost shell will help you to determine what valency that element will have. Whether it is going to lose or gain to become stable. Because every element, to become stable in chemistry, it has to obtain either a duplet or octet configuration. Duplet has to do with 2. Octet has to do with 8. In other words, the innermost shell of every element is meant to have maximum of 2 electrons. In the outermost shell should have maximum of what? 8 electrons. Now, in a situation whereby the element doesn't have enough to be complete, the element will either lose the electrons or gain electrons to become stable. Just calm down and follow the video. For instance, let us arrange oxygen around the electrons of oxygen around the nucleus of an atom, like oxygen. You ask yourself, what is the atomic number of oxygen? Atomic number of oxygen, check: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, 8. So, atomic number of oxygen is what? 8. Now, arrange it around the nucleus of an atom. So, you have innermost shell should have maximum of what? 1, 2, 3, 4, 5, 6, 7, 8. Remember, the outermost shell should have how many? 8. But now, this outermost shell has 1, 2, 3, 4, 5, 6. Remaining what? 2. So the configuration now is 2, 8. 2, 1, 2. Sorry, 2, 6. Now the question is, will oxygen gain the electron to become stable to complete itself, or will it lose? It will lead us to the topic metals and non-metals. So this is the simple configuration of oxygen, 2, 6. And the valency of oxygen is going to be what? minus 2 it is going to borrow. But before I continue with this, let us explain what metals are and what non-metals are in terms of electron gain or loss. Metals are those elements that ionize by loss of electron. Metals are those elements that ionize by loss of electrons. What is ionize? They try to become stable by losing electrons. Why? They will check themselves and say, let me rather lose this electron and become stable than this thing disturbing my stability. While non-metals are those elements that gain electrons, when they ionize. They ionize by gaining electrons. They are borrowers. They are beggars. For instance, this oxygen now, it is easier for oxygen to borrow 2 more to become stable and have 8 here than to throw away 6. That is why oxygen is a non-metal. Remember, metals are givers. They lose electrons. So they give out to non-metals for them to become stable. While non-metals are those elements that gain electrons to become stable. So, with the idea of valency, you can differentiate between metals and non-metals in terms of electron gain or electron loss without stress. Now, the valency has to do with the number of electrons that element is going to either gain or lose. Are you following me right now? So, oxygen has 6 in the outermost shell, so it can borrow 2 to become stable. When it borrows 2, it is minus 2. A borrower is kind of a negative person, but while a giver is seen as a positive person. Do you understand? So, oxygen has a valence of minus 2. Let's try something else. What of sodium? You ask yourself, what is the atomic number of sodium? When you check it, you know that atomic number of sodium is what? 11. Now, let's fill it in. Innermost shell, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. How many does sodium need to become stable? Remember, it has just 1 in the outermost shell. It will need up to 7. Who will lend sodium up to 7 electrons? No one. So sodium can easily lose this 1 electron and the shell to become stable. So on a normal, sodium is 2,8,1. So it will lose 1 electron to have a valence of +1, +1. Because it is a giver, it is seen as a good person, a reducing agent, and it has a valence of +1. Let's try out another one. Let's think of another element. Let's look at magnesium. Magnesium has atomic number of 12. Now, the innermost shell should contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The question is, will magnesium gain or lose? Remember, we are looking for 8, and it has 2 in the outermost shell. Who will give magnesium up to 6? So, magnesium will lose 2 electrons. That is valence of +2. Very simple. And these valencies are what they bring into combination, into bonding. We'll still look at bonding. These are the things they bring in when they want to bond. Now, when someone asks you, valence of magnesium, you said is +2, +2. Valence of sodium +1, valence of oxygen -2. Hence, that is why when you check the periodic table, elements in group 1, 2, and 3, remember group has to deal with electrons in the outermost shell. Those that have electron 1, 2, and 3 in the outermost shell, they are metals. They are what? Metals. But those elements that have from group 5, 6, and 7, they are non-metals. Why? If an element has 7 electrons in the outermost shell, it's looking for just one. It can just borrow. So it is a non-metal, borrower. They are non-metals. If it has 6 in the outermost shell, it can borrow 2 and become stable. Non-metal. If it has 5 in the outermost shell, it can borrow 3 and become stable. They are non-metals. But if they have 4, they are confused. They are metalloids. They are in between metals and non-metals, so they call them metalloids. Hope you understand what valency is. I believe that this lesson must have taught you to differentiate between metals and non-metals in terms of electron gain or loss. Metals are givers, they lose electron, while non-metals are they are beggars, they gain electron to become stable. And with this knowledge, you can give their valencies anytime, any day. Before I end this lesson, I would like you to work on this. What is the valence of calcium? And another one, valence of sulfur. I want to see that in the comment section. With a simple idea of group and period, you can tell what their valences are. Please comment on this, give your answers immediately. I'm going to look into them. With that, I'll be ending this lesson. Wait for me. Catch me again in my next video. I believe you enjoyed yourself. Have a beautiful day ahead. Thank you.